So first a bit about me. I've got more than 10 years experience of consulting and working in identity. I've done a lot of consulting and open source work, first on SAML 2, which is, by the way, a horrible protocol. Don't use it. But I've used it a lot, and I created a quite successful open source package for SAML 2. So if you have to use SAML 2, you can use my packages. And then I've been moving away over to consulting and training on OpenID Connect and OAuth, which are the protocols you should use. They are modern, they work better, they are more secure, all of that. I work for Duendo Software nowadays, the new home of Identity Server. But first start with some history. So this timeline starts as 2005 with SAML 2, which was groundbreaking because it was the first single sign-on and authentication protocol that was built using web technology. We had single sign-on for web applications before that. You remember Windows integrated authentication, where you could, if you were in a corporate environment, in an internal website, and you were a member of the Active Directory or NT domain even earlier, then you were automatically signed in. But that was not built using web technology, because that was based on the browser having an NTLM v2 or Kerberos implementation in the browser. But SAML 2 came up with this notion that why don't we just make things that looks like ordinary web request to the browser. When the user enters an application, that application redirects the user to an identity provider where they prove their identity, and then we get a proof or a token of who the user is back to the application that the application can validate and consume. And all of this, I mean, 2005, what was the most modern technology for data interchange? XML. So all of this was done in XML for SOAP, and signature XML digital signature standard, which is an even more horrible standard than SAML 2 itself. And just overly complicated. But hey, it was enterprisey and SOAP. Around at the same time, the internet companies were growing and found out we need a way to do single sign-on and to do API security on the internet using modern technologies. I mean, JSON, JavaScript, doing things in the browser. These protocols, XML style, are run on a server-side component. It's nothing you want to implement in JavaScript, and it was never meant to. While OAuth was meant from the start to be usable in the internet era, unfortunately, OAuth 1.0 had some drawbacks, so it was just a few years later that OAuth 2.0 came along. And that was groundbreaking, and we are still using OAuth 2.0 more than 10 years later with the fundamentals unchanged, which proves that this was a well-designed protocol. While SAML 2 and W's Federation, W's Trust was a designed by committee product, I mean, when reading the SAML 2 spec, it's clear that if there were two opinions on how to do something, both were included as options in the spec. While in OAuth 2, when reading that spec, there is one way to do things, and it's a simple way to do things. But it's still based on a thorough threat modeling, contemporary security research, a solid security model, so it works. Then quite a few things happened, and we are now a decade later coming to OAuth 2.1, which is a software thing. It should have been released last year, I think. It's still not released, but it's coming any day, probably. And as it is a software thing, we use something that looks like semantic versioning, 2.1, and that means it should just add a few things, right? It doesn't. It removes things as well. But that is actually a good thing, because these all recommendations and additions and stuff that happened in between here actually said that part of the OAuth 2.0 spec, part of the things we had here, part of the options turned out to be bad ideas. So there are now recommendations and further specs that says don't use that thing from the original spec, or like the PKCE spec, use it, but add this thing as well. And now in 2.1, the idea is to consolidate it to what we actually do recommend right now. It's a bit like these books. I read the right one. I never got around to read the left one. I don't know if I should. But this talk is very much like the right one. The JavaScript, the good parts, or OAuth, the good parts, the thing that you need in the most common setups, in 95, 99% of the cases, the things I will be showing today will be the things that you will be using in real-life scenarios. Then, if you're doing things like smart TVs or stuff, you might need the other ones. So the agenda today is first an introduction to why does OAuth exist? What is the problem it solves? What are the protocol flows for typical application and some typical application architectures? Finally, if you want to make someone working in the identity space cringe a bit, you say that log in using OAuth 2. So I will talk about why OAuth is not a user authentication mechanism and what OpenID Connect is, and finally some further reading. So first, why does OAuth exist? Well, as I said, OAuth was born on the internet. We had SOAP, we had W security, etc., that were used to secure web services, and it was extremely complicated. And if you had tech stacks from different vendors, they were probably not totally 100% compatible. On the web, we wanted to be able to call HTTP APIs. And a very simple way to secure an API is to use an API key. That is still commonly used, isn't it? But the API key is a password. So what if we want to have the client application being able to call multiple different APIs? Then we are essentially reusing our password. And that is something we should not do. We are also sending that API key along with every single request. There is the risk that it gets logged in some server-side logged, error logs, whatever. So we maybe should be using something that is a bit more short-lived, and if it gets stolen, it's not that bad. And that is a token. And this is actually something that SAML2, concept SAML2 got right, mostly at least. The basic ideas of SAML token is right. A token contains an issue and a signature. Who said this about the user? Who vouches for this user? And there's a digital signature in here to prove that this token was actually issued by that issuer and has not been tampered with since. There's a time window for how long is this token valid. There is scoping, meaning that this token is not valid everywhere. It's valid for specific APIs. This is an important security feature, because if I am implementing a low security API and I get an access token sent to my API from the user, without scoping, I could take that token, turn around and call a high security API over there and do something bad. But thanks to scoping, the token I receive is only valid at my API. I cannot turn it around and call another API. So if you have different producers, different teams, different companies producing APIs, you definitely do want to have separate scopes for them and ensure that they cannot do a cross-API attack or request. We have some information about authentication. How was the authentication done? In this case, password, which is the normal thing, but it could also indicate we have a two-factor authentication, mobile bank-ID here in Norway or something like that. And that is something that the API can use to decide to give access. So it might be that we have an access token saying that you are the right person, it's an access token from the right issuer, it has the right scope, it's a valid time, but this part of the API actually requires a stronger authentication than you use to sign in. And finally, claims, just key value pairs, and a flexible way to just convey whatever information the API might need. And this was great and working as long as we had the enterprise-y architecture where where typically the APIs, the client application, and the authorization server all belong to the same organization. But nowadays, for example, if I invent this perfect Google widget that makes you all never be late again to any meeting. So this is a nice widget that everybody would like to use. I create that widget so it can be usable with Google Calendar. But I'm not affiliated with Google. It's you that found my widget. And I have that widget running on some service. And then I want to be able to call, or we both want that my widget is able to call the Google API on your behalf. And SAML 2 and WS Trust was really never designed around this, but OAuth was. So OAuth has this concept of a resource server, or that is an API, but I'm using the terminology that you would find in the OAuth spec. So if you read the OAuth spec, you will recognize this. Some products use this terminology as well. Some other products would call this an API or whatever. In OAuth, the resource server do trust the authorization server. This is really the only two things that trust each other. And the authorization server's role is to decide if a client application is authorized to use a specific resource or API. Then we have clients. It could be a browser-based single-page application. It could be a mobile app or some server-side thing. A server-side thing could be a machine-to-machine communication, or it could be a server-side web application. We differentiate these between public and confidential clients, and this is a very important security distinction. If we start with the server, if you have something running on a server in your data center under your control, you can keep secrets on that. You can put in a client secret that is a password or a private key for a certificate in the config, and it stays on the server and is secure. But if you have the client application actually running as a single-page application in the browser, anyone who knows how to open the browser dev tools can get the information out. And the mobile app, the same. It runs on a device under the control of the user. It's downloaded, publicly downloaded from the app stores, etc. So we cannot put secrets in there. But these are the apps. Then we also have the resource owners, or as we usually refer to them, users. But in the OAuth terminology, they are resource owners. And that works quite right. I mean, OAuth is about protecting the resource. The resource here is my Google Calendar, and I own the information in my Google Calendar. The basic flow is that we do an authorizer token request to the authorization server, we get an access token back, and then we use our access token to access the resource. When we do the call with the authorization server, we probably authenticate using, for example, a password, a long-lived password, but the idea here is that the password is only entered on the authorization server. We do not send our passwords to all the APIs or resources. And also, the password is only used in a very specific request. We are not using and exposing the password for risk of being intercepted by being sent along in every request. When we do send the authorization request, we also need to send in a scope parameter to ask about what APIs are we trying to reach. In the case of the Google Calendar, I should probably ask for read access to your Google Calendar. I should not ask for a scope that gives me right to send Gmails on your behalf. That is probably wrong for a Google Calendar widget. We can look at some real-life examples of GitHub scopes, and they actually have a quite decent scope architecture. We have, for example, user, which is a master or main access to the user information, and then we have some more fine-grained scopes if we just want to use a subset. That is good because if I want it all, I do not have to repeat all of these, but I can just refer to this. This slide is also a great proof that naming is hard. What is the name standard here? Is it object colon action or action colon object or underscore? It's repo underscore deployment, but repo colon status. So, well, it works, but naming is hard. Google is a big company. They take naming very seriously and probably had someone with experience back from the XML days because all of their scopes are URLs. That they are URLs doesn't matter. From the OAuth perspective, it's just a string without spaces that happens to be a URL. But here we are using a registered domain to ensure uniqueness, and we are using paths. And probably this gives you kind of a namespace where you, as a team of Google, you're probably assigned a namespace /auth/gmail, and then you can put whatever you want after that. So that are the basic terminology. Over to how to use it and the two protocol flows. Remember, there are a bunch of different flows in that large complete reference, but the good part, we are only using two flows. The first flow I want to talk about is client credential flows, and this is for machine-to-machine communication. There is no human being or interactive user present, or if there is, we don't care who it is. We only authenticate the client application. We know what client application is making the call. The protocol flow is extremely simple. We make a post request to the token endpoint on the authorization server. We get a response back with the token, and then we can call the APIs using that. Let's have a look at the token. The token is a JSON web token, typically, but as I will soon get to it, not always, but typically it is. It contains the same elements that we had in our SAML token we reviewed earlier. Issuer and signature. We have the, this is non-happy. We have the issuer over here. We have a signature at the end. We have a time window. The IAT is issued at an expiry, and those are Unix timestamps, which indicates the validity period. We have the scope. This token is valid for API 1, and we know the client ID. That is really the only information we get about the caller for the client credential token, because we do not have any user to describe present. We just know it's what client it is. When we want to use this token, we transmit it via the authorization header and call the API. So some token processing rules. Remember that I said that in OAuth, the only parts that really trust each other and have an intimate relationship is the API and the authorization server. And access token format is a private implementation detail between those. So if you are looking at the OAuth 2 spec, it says nothing about the authentication, the format of the tokens. So actually, at least a few years ago, if you signed into Azure AD and got an access token to call the Microsoft Graph APIs, that was not a JOT. It was a proprietary token format from Microsoft that you could, I don't know how to decode it, but it doesn't matter because I should not. As a client, I just forwarded it to the Microsoft Graph API. Azure AD can perfectly issue JOT tokens as well if you have third-party APIs, because if you produce the API, you definitely do want to know what the token format is because you are about to consume it. If you're an API and want to process the token, validate it, there are some validation rules. You must validate the signature, and you must also validate the signature algorithm is valid. In the spec, there is actually a signature algorithm called none. And the idea was to use it for scenarios or flows where a signature is not needed or for testing purposes, but it turned out that there was an era where there were quite a few implementations that just checked that there is a signature with an algorithm, and they allowed signature algorithm none, which is, of course, totally unsecure. You must check that the type is AT plus JWT, an access token in Auth format. The issue must be an expected value. And why do we need to check the issue for an expected value if we also check the signature? Well, in the case for multi-tenancies, such as Azure AD, each tenant, Azure AD tenant gets their own issuer, but Azure AD has a common set of signature keys. So the signature might validate, but it turns out it was not my Azure AD tenant that issued it, but someone else's Azure AD tenant. The current time must fit, and the scope must be an expected value, so I'm not accepting access token that were meant for another API. So let's take an example. I'm too lazy to do. So this is an example where I'm a simple console application where I'm first using an identity model library to request client token. From the token endpoint, I have a client ID. This is console, a client secret, which is secret, and the scope I want to use. And then I print out that, and then I also use it to let's see here. I do call an API and attach it as a bearer token to the outbound API call. A typical flow. And so .NET Run. We can see the token response was 200. We got this JSON back with the access token. The thing that is good to notice that if you take JSON and base UTF encoded and then base 64 encoded, it always starts as EY capital J. So whenever you're working with this, if you see these letters EY capital J, it is definitely base 64 encoded JSON and probably a token. So one of these things just to scan for when you are trying to find out in local storage or whatever to see what data is here. Remember that the token has an expiry time built in, but as a client application, I am not allowed to inspect the token to find that expiry time. So I also get the expires in the response, because this is for me to consume. Also the token type bearer and scope API 2, that this is for API 2. Once more, the scope is of course encoded in the token, but I am not allowed as a client to inspect the token. And then I'm calling an API. This API actually just returns hello API and writes out the claims it found in the token. But I want to, we can take the time to I'll just switch screen sharing here to, no, mouse to duplicate. I just want to show you how you can decode the code. So if I have the token here, if I select it, it's up to here, right? And then I'm going for a browser. We have a browser. Here we can take a browser. Jot.io is an excellent online tool. I can go here, paste it, and we can see that this was the actual token I got. The header with an algorithm type is correct, AT plus JWT, issuer, I'm running my identity server in localhost 5001 and scope. So there are available tools just to simply inspect it. So next time you want to try to find out when you inspect an application and check local storage contents, if you see EY as the starting string, go to jot.io and see if it is a token that you could actually use. Okay, that was a very quick demo, but yet a demo, and I want, of course, to extend once more when I'm on here. So that is using the token, but remember the lifetime of the token is fairly short. And to handle that, what happened? Oh, I want to extend And I never knew that if you use the clicker to point on that selection screen, it actually flipped to the settings. So let's see if I can use the clicker now. Yes. So just background, 401 versus 403. We all have these nice hoodies with the 401 on the back. It means we don't know who you are. But we have 403 forbidden, which means we know perfectly well who you are, but you're not allowed to enter here. And we can actually use that for token management. So if we have a token that is valid for 1 hour, one way is to keep track of that expiry time we got and renew ahead of time. The other one is to use the token, and as long as it works, it works. And then if we get a 401 back, it means that the API no longer accepts my token. It used to accept it up until 5 seconds ago, but now it doesn't. That probably means it's expired. And if you have resend some mechanism already in your API, you might as well get a new, on a 401, you might as well get a new token and retry the request. My personal gut feeling is that I think proactive is a bit more elegant, that we shouldn't try something. We should keep track of the timing, but both works. And to get a new token, I mean, this is a machine. We can just tell it to go to the token endpoint once more. Just repeat the same flow to get the token again. But that's quite boring. What is actually a bit more useful probably is interactive applications. And to be honest, client credential flows, if you have an API set up in an API space that is only called by other machines, and it's a small scale where it's just one API, most people just use API keys, and that's fine. Client credential flows are usually used where you have APIs that are both called in a machine-to-machine scenario and in an interactive user context, and you want a unified security model where you just use access tokens for all access control. So an interactive application is designed to incorporate a user, and we need a way to get new tokens. So while the client credential application, we could just tell it that, okay, after an hour, go essentially log in again, because it's a machine, we can tell it to do that. But if you have an interactive application, if you, after 1 hour, pop up a message to the user saying, sorry, you are logged, your access token expired, anything you didn't save is now lost. To continue, please go log in again and you will get another hour. That is not a great user experience, right? So we need something that enables the application to renew access token in the background. Just an overview of the protocol is that we have, once more, this too late thing where we have a front channel request. The browser redirects the user to the authorization server, and all the interaction happens on the authorization server. We get a response back, and there's a back channel interaction where the client application authenticates itself and proves it's the right valid client application and retrieves the access token. This also enables us to keep the access for a server-side application, confidential client, remember. It means we are able to keep the access token out of the browser. The user will never see the access token passing by, thanks to this back channel call. The front channel request, when we do that, we need to tell the authorization server quite a few things about the client application and where to redirect back, etc. I'm coming from the SAML2 background. In SAML2, everything were XML. So of course, this request in SAML2 was XML. And then it turned out that sending XML as a query string parm is a bad idea. So the base64 encoded it. And it turned out that XML is extremely chatty, so it turned out to be too large for query string parm, so they decided that let's UTF encode it, deflate, compress it, then base64 encode the result and put that in the query string. When OAuth came along, the OAuth authors sat down and thought, well, they obviously studied the SAML2 standard because that was an existing thing that worked, and they tried to pick the good parts but not repeat the bad parts. So they sat down and thought, okay, we need to convey a bunch of parameters across a redirect. Is there anything built into HTTP that we can use to just send a few parameters? We could do JSON, right? We could do deflated XML, or we could just use a query string parameters and just send the parameters as query string items. What we have here is the client ID, where it says who is the client, the redirect URI, where do we want the response when we redirect back, response type equals code, that is selecting the authorization code flow, and state, which is some state of the client that is echoed back, and also code challenge. I will talk a bit later on that. Then when we are at the server, we have user authentication, where this happens on the web. And it is a web page that is under control from the authorization server. That means that the client application has no idea how the user is authenticated, what authentication means. If we have a centralized authorization server and we want to add a new authentication method, we do it at the authorization server. We do not have to update all our clients. It could be username, password, an external account, mobile bank ID, whatever. If we are in a corporate setup, we are probably done here. But if we are on the internet with this calendar widget, which is a third-party application, we probably have a consent screen as well. Because you as a user has a say, what do you want to let this client application do? What APIs do you let this client API access? And in the end, how many of you actually do read these consent screens before clicking OK? Well, half the room. That's great. Well, let me tell you, how many of you have someone you know who had their Facebook account hacked and who created a new Facebook account? Was their Facebook account hacked? Nope. They used their Facebook account to log into some shady lottery scam, whatever. And they didn't read the consent screen, and they gave that shady site consent to post to their timeline. So in a moment, we will get back to how to help your family to unhack their Facebook accounts instead of creating a new account the next time. But first, a few more details. Once we are past that consent part, we have the response, which is a code, essentially handle or a reference to the authentication that just happened, and the state is echoed back. Then we have the back-channel request to the token endpoint with the code, the redirect URI, authorization. The client application sends along its client credentials, basic authentication to prove it's the right one. Or in case it's a public client, it sends along the code verifier, which is kind of a temporary password that the client created just for this request. And that is a mechanism that was introduced for mobile phone applications, where on a mobile phone, the redirect happens back to a claimed URL which opens an app. There is no central registry for these custom schemes. So a rogue app could register the callback URL of a legitimate app and steal the code. But with code verifier, it means that to redeem the code, you need to have the code verifier, which is a one-time password the client application came up with. But how does the authorization server validate the verifier? Well, let's go back to the front channel request. Because in the original request, the client sent along the hash of the verifier. So this authorization server has the hash and can now take the clear text code verifier it received, hash it, and compare it to what it done. And by this, the authorization server can know for sure that it's the same application instance doing the back-channel call to acquire the tokens as was initiating the redirect. We have a back-channel response with an access token, a refresh token, and the same expiry time. If we look at the access token we received, it contains a bit more information here, and I know it's low down on this monitor, or screen, but we have now a sub, which is the subject identifier, the ID number of the user, and authentication method reference. We can also possibly have given name, family name, email address, other information that we want all our APIs to have about this user available without having to make outbound calls. And of course, it's a signature on it as well, even though it's not shown here. So back to the token management thing. This token is valid for 1 hour. When the validity period, or this is not valid for 1 hour, the difference is just 200 seconds, I think, which is very short. So 200 seconds, in a bit more than 3 minutes, we need to ask the user to sign in again, which is not okay. I've seen setups where people solve the token management by extending the access token lifetime for 8 hours, a full working day. And then when people were working a bit overtime, they got kicked out, so they extended it to 12 hours. And then they had people working a lot of overtime, so they extended it to 16 hours. And then, because then they had the idea, if people log on in the morning, 16 hours will time out before the next morning. And then they had someone sign in the afternoon, which meant the session was still valid the next morning and timed out right as they had got up to speed with their work at 9. So don't do that. The mechanism we want to use is refresh tokens. And the idea is that we get a refresh token on the initial token request. And once the access token expires, the refresh token is long-lived, and we can send a request to the token endpoint for a refresh token. Sorry, for a new access token. And we get a response with a new access token and probably a new refresh token. And this can be done right when the access token expired, or the refresh token can have a longer lifetime. I have refresh tokens that have been around for years. My CI/CD server that has access to my GitHub account, that's a refresh token that has a very long lifetime. So why can we have a long lifetime on the refresh token but not on the access token? Well, consider if one of you managed to steal my wallet, you would find some money and some credit cards. The money are bearer tokens. If you have my money, my bills or coins, you will be able to go shopping for them, and there's nothing stopping you. If you have my credit card, you can go shopping with my credit card as long as you use low enough amounts, you can just blip it, and just until I found out about it. Because when I found out about it, I call my bank and revoke that credit card. The credit card is a reference token. And the refresh token is also a reference token. It's something that is an index into a database. And if I remove that line in the database, I can revoke the refresh token so it's no longer valid. And that is exactly what you can do. If you go to your Google account, your Facebook, GitHub, or whatever account, you can see a list of approved OAuth 2 applications. That is a list of refresh tokens, valid refresh tokens. And this is why you want to go to unhack your family's Facebook accounts. Because if you go here, you will see that they have allowed that shady lottery site full access to their Facebook account. And if you revoke that refresh token, that site is gone from the timeline, and they do not have to register a new Facebook account. A more common usage for refresh token is to just use it for the duration of a session, so that when we sign in the morning, we get a refresh token, so we can get new access token throughout the day. But when we sign out in the afternoon, we do not keep it around. Then it's polite to revoke the access token at the end, just to get it off that list, because you're no longer using it. So those are the two main protocol flows: client credential flow for machine-to-machine communication, authorization code flow, together with PKCE proof key code exchange, that code verifier for interactive applications. And the reason that we can now recommend authorization code flow for all kinds of interactive application is thanks to PKCE, because it turns out that together, authorization code flow with PKCE solves all the problems that we tried to solve using different flows previously. Makes life a lot easier. I want to talk a bit also about application architecture. So machine-to-machine scenarios are simple because it's a console app running off some batch scheduler or whatever. But interactive applications come in a few different flavors. We have browser-based applications that can be server-side application or single-page applications where the application actually runs in the browser. And we have non-browser-based applications such as mobile apps, desktop applications, well, native apps. If we first look at browser-based application, the classic server-side application contains an OpenID Connect or OAuth client library, session management, token management, UI assets. So all of this runs on the server. It's a confidential client, and the tokens stays on the server in the data center, out of reach from cross-site scripting, rogue plugins in your browser, etc. And I'm really a bit disappointed with the scheduling today, because a talk I would really have loved to be at is Philip Derrick's talk, which is in the next room at the same time. And because he explains a lot about why the browser is not a very secure platform. So go watch his video afterwards for more strong arguments on why it's a good idea to keep everything on the server side. Because the problem is really single-page applications where all of this runs on the client side. I mean, OpenID Client.js from Brock Allen was a full OpenID Connect client, including RSA public-private key crypto signature validation done in JavaScript. I mean, he's an excellent JavaScript developer who created and maintained this piece of software that worked across browsers, all different browsers for multiple years, and eventually he got a bit tired of browsers changing all the time. And also for the reasons that the browser turned out to be non-secure. And one more thing, the session management spec of OpenID Connect for single-page application relies heavily on hidden iframes doing cross-site requests and tokens being transported there. And modern browsers that are more and more privacy aware are blocking that. So let's take another demo, just why. I'll go back to duplicate if I find my mouse. Let's see here. Where do I have? We can just take that and So I'm opening an incognito window. I'm not cool enough to use a Mac, so I'm using Chrome on Windows, but I flip on this block third-party cookies. And I go to sign on to Microsoft Teams. I'm redirected to the Azure AD login prompt. I'm entering my password. I need to find my phone because, of course, I have two-factor auth enabled. And yes, I want to prove that sign on. And yes, I want to stay signed on, whatever. It's in private incognito window, so it doesn't matter. So I've signed on to Teams. And Teams starts. And I'm, well, signed on to Teams, am I? The problem here is that Teams uses the session management part of the, or the session management implementation that is mandated for single-page applications, and it relies on cookies being sent in third-party requests and hidden iframes, and it turns out that it says in Swedish here, if you want to open your web app, change your web browser settings to allow third-party cookies. Switch off the privacy control. This is not how I would prefer to solve it, to tell users to switch off privacy control. So what do? Well, we have to accept that the idea to run single-page application, do full OpenID Connect in the browser is a dead end. And I still should, sorry, I still had that change in screen focus. So what we should do is to have the right screen settings and show the presentation, and then, yeah, from this place where everything is in the browser, what we should do is to go to this, where we move all the OpenID Connect handshake, session management, and token management to the server side. So essentially, and then let the browser have UI assets. So essentially, I said at the start that we have two kinds of applications, server-side rendered and single-page application that are client-side rendered for web applications. But it turns out that from an authentication perspective, going forward, we really just have one type of application, where we do the authentication on the server side, where we keep the tokens on the server side. Then it comes into sub-variants where the content rendering happen to be done on the server or in the client side. So, what about non-browser-based applications? Well, non-browser-based applications, a mobile phone application, they are really exactly the same. We are redirecting out to the authorization server where authentication happens on the web. Advantage of that, remember that Google Calendar widget? Back in the very early days, you could come across applications where it said, sign in with Google, please give me your Google password in my app. Would you ever give me your Google password? Scott, please. Nope. So using a web browser actually is a very good thing for the users as well, because that web browser indicates you are now on Google and it's a trustworthy, if the web browser says Google, it actually is Google because of HTTPS, we know that. So we can teach our users to not enter the main password in various applications, etc. They should only enter the main password in one place. And also, if it is a device where I'm already signed into the browser, I get single sign-on into my mobile app. Isn't that great? And then we are coming back. If you click a link on an Android phone to maps.google.com, that link will not open the web browser in maps.google.com. It's actually the same on Windows. Maps.windows.com. Let's see if I can move this over to the right other screen. So if I, on Windows, open maps, https map.windows.com, click OK. I had to put it on this monitor. I actually get the Windows map app. I didn't know it existed before I found out it was a great demo. I've never used it. But so this is claimed URL, which means that if the authorization server redirects to claimed URL, the app is opened and can retrieve the code from the response back and then do the back channel call to get the token. Finally, I want to talk a bit about OpenID Connect. Remember I said that log in with OAuth and people will cringe a bit. So the problem here is that if we look at a pure OAuth flow, we have the front channel login and then the back channel ending up with retrieving an access token. What can the client application do with the access token? Can it read it? No. It shouldn't consume it. It can just forward it to an API. And also, when talking about single sign-on, I usually want single logout as well to be able to sign out. Is there any notion here about establishing a session? Anyway? No, it isn't. So that's why OpenID Connect is added as an extra layer on top of OAuth 2. And the flows looks kind of exactly the same. We just add a few more scopes to indicate we want the OpenID Connect extension to OAuth. But now we will get another token back. We will get an ID token. And while the access token is for consumption by the API only, the ID token is for consumption by the client application only. So the ID token should never, ever be forwarded to an API. We can even see that looking at the audience says client. This is meant to be consumed by the client. And it contains subject ID and name, some information about the user. The flow to get it is, well, the same front channel request and back channel response, where we get an ID token and access token back on the same time. I think we actually have time to look at a demo of that as well. I do have such a demo somewhere here. Let's go here, and I'll just flip to pieces. No, not pieces screen only. I want to. I mean, it's a great idea with this table looks nice, but it's sloping, which means my mouse is constantly just running down here. So let's go to MVC1, which is another client I have here, .NET Run. I'm still running an identity server in the background. And obviously, let's see, 5002. Localhost 5002. So if I open the browser DevTools just here to be able to see a bit what's happening, I'm clicking the privacy page. We can see that the privacy page requires me to be authenticated, so it redirected me to the authorized endpoint of the identity server. Looking at the header, the payload, we can see, no. I want the entire timeline, please. Authorize payload. We can see that I'm sending in a client ID, MVC1, redirect URI, where do I want the response back? Response type should be code. I'm requesting a bunch of different scopes. Offline access indicates refresh token. And I have a code challenge and code challenge signature method indicated. I do log in here, Alice. And I see a post to the redirect URI back with the code. Then I cannot see the actual tokens here. I cannot see the retrieval of the token because that is a back channel call from the server side. But if I go to identity server, I can see that it actually had a request to the token endpoint, MVC1 client ID with an authorization code. This is the code. And code verifier, all of that. So there was a back channel call. And I can see I'm signed in and has established a session on this side. So what mechanism do I typically use to establish the session? Can we see that from sign in OADC in the headers, that it's doing something to preserve state? Okay, this is a lousy joke, but I do have something for the one who can tell me what mechanism we are doing to preserve the session. Come on. Cookies. Who wants cookies? Okay. Let's see if I can do this. Oh, broken cookies. Sorry, but there are cookies. Okay. So finally, a bit of further reading. The OAuth 2.1 spec is quite readable, actually. OpenID Connect spec as well. And Dominic's post about 2 is the magic number, where he argues for these two flows. Also about the backend for frontend pattern, where we use this backend for frontend for our single-page applications to, from an authentication perspective, turn our single-page applications to backend applications. I have time for questions, if there are any. A few questions. Yes?
Yeah, I'd like to learn a little more about what you're saying about that design where you offload all of the, where you moved all the authentication stuff up into the server.
Yep.
So if you're moving all of your token management, you said that the client never sees the token.
Yes, because
How does the client authenticate? Sure.
Because the client just calls the server on the same domain, and we have a session cookie. And I should, of course, mention that if you just stay in this room, Dominic will be doing a 1-hour talk on the backend for frontend pattern right after this.
If I may continue on that,
Yep.
why is it better to use a cookies-based session instead of giving the client?
Because a cookie can be HTTP only. So it is kept out of reach from JavaScript, including cross-site scripting, any kind of that. Also, the cookie is only valid on that specific frontend. So it's not, an access token is somewhat higher value because it's probably possible to use it on multiple APIs. There are also some performance advantages, actually, because, I mean, ideally, you would have this single-page application that, or a client application that calls generic APIs that are totally reusable. But in real life, how many APIs are really reused across different applications? In real life, we have a lot of APIs that are dedicated for a specific application. So why not make it more simple and put it on the same host? And also, if we actually need to call other services, we can have an performance improvement because you can make one call to the backend for frontend that is a high latency call across a mobile network. And then you make multiple low latency API calls from the BFF to backend APIs. That's within the data center, and you return an aggregated response. So there are many advantages: security, application architecture, convenience, and performance from using a BFF pattern. Yes?
I had a question on the scopes property.
Yep.
So you mentioned that GitHub and Google, becomes quite big, the amount of scopes and combinations you can have.
Yep.
Two questions. So what if you get like very complex sets of different types of scopes? Does that impact performance?
So if you get a complex set of different scopes, first of all, if it impacts performance, no, not really. It's just an extra parameter. However, if you have a really complex scenario with a lot of applications where there are third-party applications that might have defined the scopes, so you have two applications that pick the same name for a scope and in two APIs, then there is a concept called resource indicators where you add another layer and a hierarchy on top of the scopes, so you can have different access tokens for different resources. I didn't go into it here because it's a more advanced concept. In real life, as I said, in many cases for internal use, you simply can have one scope, backend. You do not need to use the scopes. And then sometimes you need to use a few scopes, but it's a perfectly valid scenario that you have that, and that's when you can add on the resource indicator as well.
Okay, that makes sense.
Yep. So, and you had another question?
Well, so my second question actually already answered.
Okay, great.
If it makes sense to summarize into it, for example, using one word backend or whatever, but you already mentioned.
Yeah, so if it makes sense to summarize, so if, I mean, scopes is one of those you ain't gonna need it things. So don't introduce scopes until you need them. Don't introduce scopes until you have multiple clients and you want to be able to, on a per client application basis, partition your API. You can still have, you do not need scopes to have different privileges for different users, because that are user properties. Okay, I think time's up, so I'll be around for most of the day if you have questions, so please catch me if there's anything. Thank you for coming.